9-7 Theoretical and Experimental Probability. If you want to take a minute and hit pause and copy this down, we'll discuss it. Go ahead and do that. Theoretical probability is based on what should happen when conducting a probability experiment. Basically, it is based on theory. Okay, there is no data backing that information up. So what we have done up to this point was theoretical probability. You know, what is the probability that we're going to roll a 1 on a number cube? Well, since there's one number that is a 1 on a number cube, it's 1 out of the possible 6 numbers. That is based on theory. That's what should happen. Experimental probability is based on what actually occurred during such an experiment, based on data or a survey. So basically, you're going to go out and collect information, collect data on whatever topic you're trying to find information on. So you would have a chart of some sort that's going to be given to you, and you'll base it off of that information. Okay, so let's take a look at this particular problem. It says 2 number cubes are rolled 75 times, and a sum of 9 is rolled 10 times. What is the experimental probability of rolling a 9? I'm going to let you go ahead and hit pause and get an answer, and then we'll compare. So the 2 number cubes are rolled 75 times, and it says that a sum of 9, meaning adding the 2 numbers that come up on each of the number cubes, adding those together, is rolled 10 times. The experimental probability of rolling the sum of 9 is that, again, experimental, this is the data that they gave us. Okay, if they rolled it 75 times, that's going to be my denominator. A sum of 9 is rolled 10 times. Well, how many times did they roll it? Total of 10. Okay, so my answer to this then is simplifying this by dividing by 5 to get 2, and then 75 divided by 5 is going to give you a total of 15. So my answer is 2/15. That's the experimental probability. Now, can you take this and convert this into a percent? You can. Not necessary. It's an unnecessary step. It gives you another chance to make a possible mistake. So if you did make it into a percent, 13 or 13.3% is what you would get for that. But you can just simply leave it as a fraction unless it's stated otherwise. Okay, let's look at the next one. It says the chart shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Find the experimental probability of spinning red for this experiment. So go ahead and hit pause. I'm going to let you solve this, and then I'm going to also let you solve the bottom part where it says now compare the experimental to the theoretical probability of spinning red. So you're going to have to find the theoretical as well. Okay, and then compare. So go ahead, hit pause, and then we'll come back. All right, again, the chart. Here is my chart over here. These are my results of spinning that spinner. And again, that spinner would look like this. Okay, and you would have green, blue, and red in each of those spots, and that wasn't exactly the best spinner I could have drawn. More like this. Sorry about that, like a peace sign. So again, that is spun 60 times. Okay, so our question is probability of spinning red. Okay, that's what it would look like written out. So we have red, which is 24. And it's already given us that it was spun 60 times. If they didn't give me that information, then I would have to add these three numbers together, which you can double check, and they do add up to 60. Okay, so you get 24 out of 60 is the results. And again, you will always want to reduce these numbers. Okay, we can reduce it by 2, get 12 over 30, divide by 3 then, and get 4 over 10. Or you could then divide that by 2 and get your 2/5. Okay, or you could have simply taken this, maybe you multiply or divided by 6 right off the bat and got 4/10, or maybe you knew that the greatest common factor to this was 12 to get your 2/5. Okay, that is my experimental probability. Now comparing experimental to theoretical, so my experimental equals 2/5, and my theoretical is going to equal, well, how many, and again, theoretical, you're not looking at any of these numbers. They are meaningless to you, okay? Spinning red, well, probability spinning red, how many red are there? There is 1 out of a possible 3, okay? So 1/3 of a chance is what you're looking at in this situation, okay? So now the question is, let's compare. Okay, now some of you, there's lots of ways to compare. The biggest thing that you want to be paying attention to is one larger than the other? Okay, how does it match up? Are they close? Are they equal exactly? If you're not sure, then you need to make certain that they have common denominators. Okay, when you do this. So when you do common denominators, I'm going to do this over here, 2/5 and 1/3. We've got 15 for the least common denominator. That's going to be 5 then. This is 3, so 3 times 2 is 6. Okay, so my 2/5 and 1/3, they're off by about 1/15. Okay, so comparing these, are they very, very close? Absolutely they are. Only being 1/15 apart is nearly the same. Okay, so in this situation, to compare, you can list all of this. Okay, that this is 1/15 greater than 1/3. You can say that they're almost nearly identical, so that they basically backed each other up. Okay. So if you have any other further questions on this, please let me know, and we'll discuss it a little further tomorrow. Now it says, suppose you decide to spin the spinner 1,000 times. It says now to predict how many times it should land on blue. Now we have done this already. Okay, we have done this with predictions using probability. Now, since it's saying that how much it should end up being, there's two different ways. One, you can be using the experimental probability, okay, or you could also be using the theoretical probability. And what we're going to be using is the theoretical, not the experimental, okay? I'm sorry, I told you that wrong. We are going to use the experimental. We have the results, okay? So we're going to use those results. You could do both, and I'll probably show you both. But we're going to look at blue. So it's going to be 15 out of a possible 60, okay? So if you take 15, oops. And simply take this number and reduce this, which we could just do by 15, and we get 1/4. Okay, so take our 1/4, set it equal to in our prediction. So if it's 1,000 times, then we're going to say 1,000 for my denominator, and this is what we're trying to find is x. How would that ratio equal each other? Through this proportion. So we can cross reduce, or we can, which we cannot do here, but we will then cross multiply to make the equation. So we get 1 times 1,000 is 1,000 equals 4x. Divide both sides by 4, and you'll see that x is going to equal 250 times. Okay? And that again is using the experimental, using the data that we collected according to this amount, that sample space, we would get approximately 250 times we would land on blue. Okay. Now if we were to do the theoretical, then we're looking at 1/3 equals x over 1,000, and you get 1,000 equals 3x, dividing both sides by 3. And when you do that, you're going to see that you get 333, and you can say 0.3 equals x. Okay, so round this off if you like to the nearest whole and get your 333 equaling x. So in comparison, again, this is your theoretical, this is your experimental probability. In most situations, you're definitely going to always want to use the experimental if the data is given to you. If it's not given to you, then obviously you have to use the theoretical. Experimental is going to be probably the more accurate based on your situation, the people you interviewed, the environment, depending on where you were doing this at or conducting the experiment, that survey, that all plays into it. There's a lot of different factors, and we're going to discuss more of that in class as well. So experimental and theoretical probability, we're going to do some stuff in class tomorrow, and I think you'll enjoy it. Have a great day.